All right, so today we're going to be looking at completing the square. So for me, this is my favorite method for solving for quadratics. So basically the reason why I like this one so much is because you can change basically any equation in a way that makes it to where you can solve by taking a square root. And for me, taking the square root is the easiest way for me to solve these types of equations. So I like having the option to change anything into a perfect square to take the square root of it. So here's kind of the goal. We want to remember, so first, before we start this, we actually have to kind of remember what we were talking about a few chapters ago. So back in chapter 7, we did a whole lesson on factoring, right? Where if you had something that was basically if you had something in the form ax squared plus bx equals c, you could factor it and end up with two factors, right? And so you would end up with something that multiplies, two things that multiply to make the a value, which for the sake of this video, we'll call them m and n, in front of an x, plus something that multiplies to make this c value. And when you do the perfect combination of those two, you end up getting the b value in the middle. So two things that multiply to make c that we have to keep in mind, we'll just call them p and q, right? And so this is what factoring was. We would always go from this to this. Well, if you don't remember, we had a special rule for specific types of quadratics, that if you factored them a certain way, you would get certain patterns. For example, we had difference of squares. So remember, difference of squares said that if we have, oops, I did this backwards. Basically, if we have two squares being subtracted from each other, you could automatically get your answer without having to create a table or ask the question of what adds to make this, multiplies to make this. You would just know based on the pattern what the answer would be. So as an example of a difference of squares, you would have something like 4x minus 100. So if you had this answer, 4x squared minus 100. So here you have a perfect square, and here you have a perfect square, and there's a difference of the two. So you knew your answer was going to be the square root of this, which is 2x, plus the square root of this, which is 10. And then your other factor would be the square root of this, minus, see how we have a plus and a minus, the square root of this, which is still 10. So that would be your answer, right, for difference of squares. Well, something that we're going to focus on today, and we're going to kind of review another pattern that we saw, was whenever we had, whenever our answer to this was identical. Like say this was mx plus p, mx plus p. So we would always get an identical answer, and we'll call these identical factors. And this always happened whenever you had something like this, x squared plus, let's say, 12x plus 36. So the way that you know that you're going to get identical factors is by using that rule of thumb that we used, where we said, if you can cut this in half, the b value, if you can cut this in half and then square it and get this answer, then you know you're going to have identical factors. So think about it. I can add the 6 plus 6 to get 12, and I can multiply the 6 times 6 to get 36. Now, I knew that right off the top of my head because of this rule of thumb that we wrote down. And you can find this back in chapter 7 when we talked about this. You can take the b value and cut it in half. And then if you take that answer and you square it, it needs to be equal to the c value, right? And that's how you know you're going to have identical factors, right? Now, when you have identical factors, there's another way that you can write it, and this is going to come in handy right now using some logic here. Instead of writing out both factors, couldn't I just very quickly or very shortly only write one of them? And then instead of writing the second one, I can just say squared, because I'm just multiplying these two things together. I'm multiplying this factor times this factor. So the reason why this is really helpful information is because I'm going to take advantage of the fact that I have this square here, so I can take the square root, just like we were doing in the last section. So now I'm creating a situation or a scenario where I can just take the square root and solve that way. Okay? So let's look and see what it looks like to complete the square. Okay. So to complete the square, what you have to do is you have to take something that doesn't have a c value. So let's say you only have the a value and the b value, or let's say there's no a value actually. It's just 1 in front here. What you have to do to solve for a c value, to create a c value where you could create a perfect square scenario, which is what this is. This is a perfect square scenario. In order to do that, you have to create this situation right here. So basically, instead of writing c right here, we can just write this part right here, okay? So what we need to do is we need to take our b value, cut it in half, and square it. And that's what we're going to do with every single one of these. So here's an example. Example A. I want you to take this and then I want you to complete the square. So basically come up with a c value that would complete the square in this scenario, okay? So what would I have to write right here that would create a perfect square? Well, just like it shows here, I need to take the b value, cut it in half, and square it. So I'm going to take the b value, 6, cut it in half, and square it. So now I end up with 3 squared, and 3 squared ends up being 9. So if I'm going to complete the square, I need to add 9 to this, okay? And that's my answer. So if I told you to complete the square, this is exactly what I would want you to do, is to just write the c value that would make this a perfect square. Go ahead and label this a perfect square, because it's important to keep that in mind, that this is a perfect square, because if you were to go and factor this, you would end up with identical. This would actually end up being x plus 3, right? X plus 3 squared. That's why it's a perfect square, because if you go to factor it, you get the same factors, identical factors. Okay, let's do another example. Let's do an example where number might not work out so nicely, just so we can show that we can do this basically any situation. So if I have minus 9x, and this is my b value, I can still use the same method. I'm just not going to get a really nice number like I got with this last one. So I'm going to take 9, cut it in half, and square it. So 9 cut in half this time is 4.5 squared. Ooh, this time I'm going to have to get out my calculator because I don't know off the top of my head what 4.5 squared is. So I'm going to look at the cheat sheet off to the side to see. They actually give the answer in a fraction form, but I don't really like that. I kind of want to just give a decimal form. So I'm going to use my calculator to solve for that. This is an opportunity for you to pull out your calculator or go grab a calculator. So I'm going to do 4.5 squared, and I get 20.25. Okay? And so this is the number I need to add to the other side. And some of you might be asking, wait, wasn't this a negative number? Well, does it really matter? Because if I'm dividing here, I still get a negative answer here, but if I take this and square it, isn't the negative just always going to go away? You give me a plus 20.25. So yeah, it would be important to put the negative here, just so you know that you're taking a negative 9. But in the end, your answer is always going to be positive, because you're squaring it. And you can't get an answer, you can't get a negative answer when you square things. They're always going to be positive. Okay? So that's something to keep in mind, is you're always going to get a positive answer that you're adding to the end of this. Okay, so that's completing the square on that one. So let's go ahead and stop the video, and I want you to do number, let's see here, 1 through 3 on page 470. Okay, we'll stop the video and we'll come back.